Hello, and welcome to the first JavaBin online meetup in 2021. My name is Björn, and I will be your host tonight. The topic today is domain-driven design, the bare essentials, and will be given by Andrew Harmel-Law from ThoughtWorks. Before we start, I would like to give a brief introduction to JavaBin. We are the Norwegian Java user group. And in addition to organizing the Java Zone conference in Oslo, we also organize meetups in 8 different regions in Norway. Usually these meetups are physical meetups, but during the pandemic, we have chosen to stream these events online instead. If you wish to contact us or learn more about JavaBin and what we do, check us out on java.no. This presentation is recorded and will be available on Java Zone's YouTube channel afterwards. There will be time for questions and answers after the presentation. So if you have any questions to Andrew, write them in the comment section below the stream on YouTube. So let's get this meetup started and give the screen to Andrew.
Thanks, Björn, and thanks to everybody for coming. I've got some slides, so I'll just share those now. So hopefully everybody can see those. What I've been asked by Björn and everybody at JavaBin to talk to you about is a talk that I've written recently called The Heart of Domain-Driven Design, but basically it covers exactly what Björn just talked about. But what I was also asked to do, and what I've added, and so the first time this has ever been presented is here tonight, is taking the things that I consider to be in the heart of domain-driven design, and then expanding that out and taking us on the few extra steps from those kind of core concepts to getting to something that should be useful for microservices. So I'm a little bit about myself. I'm Andrew Harmel-Law. I'm a tech principal at ThoughtWorks, which means that I get to do lots of consulting projects, work with lots of different customers. I've worked in Oslo for 9.5 months in 2019 and 2020 until the pandemic hit and we all got sent back home. And since then, like most people, I guess, I've been working from my bedroom office, which gives me a lot of time to write presentations and still do some consulting with lots of different projects. So a little bit more about me and more kind of specific to domain-driven design. So I've been doing consulting for 15 years now, and I've worked in various sectors, so public and private, and I've worked across lots of different types of business domain. And 12 years ago, I came across domain-driven design. And since then, it's been making my life better and helping me deliver useful and problem-solving software for my clients. So these days, on top of that, I'm trying to spread the word about domain-driven design as widely as I can. And so over the last 6 months, and one lucky thing for me that came out of lockdown was that I got asked by O'Reilly to write a training course. So it's covers similar grounds to this presentation, but it's hands-on and it's 3 hours long. So it lets you kind of get experience trying to do some of this stuff. And it's called Domain-Driven Design First Steps. So if you want to check it out, the next run is coming up in March. And then I think the one after that is in May. So so I'd definitely check it out. I'd love to have people along. So what I'm going to do today is share some thoughts with you about what I think is the heart of domain-driven design. And so the things I want to talk about are completely contained within this book here that's up on the screen. So it's the classic book. It's the book that started all of this domain-driven design stuff. It was written by Eric Evans in 2003. And it's important to point out that there is loads of other stuff to do with domain-driven design. There's lots of other great books written by very kind of famous and intelligent and knowledgeable people. There's some really cool pamphlets, training courses, Git repositories, meetups, conferences, topics at other software conferences. There's loads of good stuff about domain-driven design, and they all build on top of this book. But what I want to talk about is some core stuff that's specifically, that's in this book. And what I really want to talk about is the subtitle of the book. So as you can see, the subtitle is Tackling Complexity in the Heart of Software. So that raises two questions. The first one is, what is the heart of software? And Eric makes it clear in his opening to part 1 of the book. He says the heart of software is its ability to solve problems for its user. All other features just support this basic purpose. And I think, and maybe it's just because I've been unlucky, but I'm sorry to say, I think and I include myself in this, I think sometimes software developers we're good at building software, but whether it solves user problems is sometimes, we could debate that fact. So that's why I want to share this, because I think DDD helps us get back to that. And the second question is, where's the complexity? So Martin Fowler, who is a thought worker, wrote the foreword to the book, and he says the complexity is the essential intricacy of the problem domain itself. So he means the complexity is in the heart. The complexity is in the business problems, and it's the complexity that our users have, and that's what we're trying to solve. So he doesn't mean the complexities around about technology and all of the different, kind of things that we get tied up with when we're trying to deliver software. So, like I said earlier, a few seconds ago, I think the Blue Book gives us the tools to tackle this complexity, and that's what I want to kind of focus on and bring to you, and hopefully explain, and maybe get you to think about and get some questions on at the end as well. There is, however, a problem, and the problem is the book is really thick. You could say there's so much in it that it's overwhelming. Something I hadn't realized until I was out in Oslo was when I kept trying to introduce people to various things, and lots of what I was talking about with my client in Oslo was things that are in this book. It's not written in the most easy to read English either. So, there's lots of information in it, but it's quite dense and quite thick and it's not very easy and simple to read. And I think consequently, that's one reason why you don't see the benefit of lots of the techniques in this book. And so therefore we've lost one of the ways to make things easier, make our lives easier, make better software for our clients and for our customers. And so that's what this talk is about. This is to focus it on some of the key bits and hopefully give you tools to explore the book in a bit more detail, and then hopefully change how you write software. So as I've said, I've kind of focused in recent years about sharing my knowledge and experience with domain-driven design, because I've been really lucky to see it giving me lots of benefits. So I've done talks about little bits of DDD. I've done talks about using DDD on gigantic projects. I've talked a lot about how to make DDD work, but I've also done talks about how I failed at doing DDD. So I've learned not just by doing it right, but I've learned by doing it wrong. And recently, in the last 12 months, I've realized that there's a thread that flows through all of these things. And this thread is 3 key concepts, and they're the emojis that you can see here. And I've realized that together, when you put them together, so not on their own, but all together, they form a steady core. And that core is a core on which everything else on DDD rests. So it's a core that I come back to, 3 key things again and again and again. And if you get these right, then DDD will work for you. And if you forget about them, then that's typically a reason why DDD fails. So what are these core concepts? So the first one is famous. It's so famous, it's got a chapter all to itself, which virtually kicks off the book. And that's ubiquitous language. So maybe you've heard about, or you've heard the term ubiquitous language. So that's the first thing we'll talk about. The second concept is core enough to have a pattern all of its own. So not a chapter of the book, but a pattern. And that's hands-on modelers. And the third one isn't a chapter or a pattern, but it's everywhere throughout the book. And I think maybe this is where the power comes from, but is missed because it's not as obvious, and that's multiple models. So what I'm going to do for the next section of the talk, and it's the kind of first big section of the talk, is introduce each in turn, and I'll focus on them and try and explain using a kind of hopefully approachable and useful way of thinking about them. Explain each of them separately as they are defined by the Blue Book. So, we won't talk about all of the other ways that people use them and all the other clever things. We'll just talk about what the Blue Book says and hopefully give you an understanding of what these things are, so that then in part 2, I can come back and share some of my experience of problems with using each of these individual things, and also how you can fit them together to make some useful stuff. And then in part 3, we'll take those and we'll build a few things on top of them to get to microservices. Because I fundamentally believe that if you want to succeed in microservices, if you get these things right and then use them in the right way to get to the building blocks, then microservices will definitely work for you. And like I say, I'm going to make sure I leave time at the end because I really want, it's really interesting hearing people's questions and stuff because I learn things. So we're going to stop for questions at a few points throughout the talk, but definitely if you've got any questions as well, just please ask them. And also you can see my Twitter handle at the bottom. I should have mentioned this at the start. So sometimes people don't think of questions at the time, but they think of them afterwards. Please either direct message me on Twitter or ask me a question on like public Twitter, and then I'd love to hear it and see what you think, or a challenge or a puzzle or whatever. So let's start first by talking about ubiquitous language. So at the beginning of the talk, I made it clear that DDD is there to help us solve problems in complex domains. So, and like we said, the problems of those complex domains are the problems that our users face in their daily work. So the problems which we are trying to make easy for them by building software, right? So to do that, what we have to do as software developers is understand the complexity, the domain complexity, the complexity of the real world for ourselves so we can take it and build it into software to solve their problems. And so what does this domain complexity look like? So I already said that for 2019 and a little bit of 2020, I was in Oslo working out in Fornebu. And so this isn't a picture of Fornebu because they look too nice and I need to look something kind of boring and banky. So, but looking for working out in Fornebu. And so their domain was banking. So our domain experts in this area, the people who worked there understood all about how banking worked and all of its tiny details, right? So again, this picture here is to kind of show that, there's lots of buildings with loads of people contained in them with lots of different information and knowledge. They knew how customers expected banking and bank accounts to work, and not just in Norway, but in lots of different countries. So they also knew that there were legal requirements that they had to meet and that their software had to help their clients meet. And as well as the changes that were coming with things like EU banking law changes and how banking worked in different parts of the world, right? So this is complicated stuff. And also they knew about how banks internally worked, how information flowed around, what processes there were, the checks and balances, and all of the different kind of culture and heritage and history of banking. All of these things were stored up in the heads of our domain experts, and much, much more. And like I said, so it's stored in the heads of domain experts. And the reason that we're calling them domain experts is because they have all of this knowledge about their domain, about banking, or whatever the kind of the problem space that we're thinking about is in their heads. And it's the reason this knowledge is in their heads is because they have to solve these problems, which our software is hopefully going to help all the time. And they've spent years doing it, so they've just gathered all of this information. But the knowledge isn't just kind of sloshing around inside their heads in the form of raw data. They've, to be able to use this information, they've packaged it up, they've packed it away nicely so they can use it efficiently. So they've sorted it, organized it, focused it, and they've constructed mental models, so kind of pictures or ideas in their heads to get an idea of how these things work, right? And so then they've used those mental models over years and years to solve the problems, and so they've become more and more detailed and accurate. And they're stored away, like I say. So this is the key point. These things are stored away, packaged away nicely up in their heads. And so the key to our success, if we're trying to solve problems for our users, is to get access to all of this learning, to get access to these mental models, and to get those mental models, or the right parts of those mental models, right? Because they know a lot of stuff and not all of it's relevant, but get that into our software. So then we can solve in software the problems that they solve before they had our software, right? Or we're trying to improve things with the software. So let's now talk about how we might do this. So how do we get at those models? We get at them, as you probably can guess, by communicating. So we communicate verbally, we'll talk to people, but also visually, we'll draw pictures on whiteboards. And the idea is, as you can see here, their mental models become shared mental models. So we build ideas and pictures and the similar kind of things up in our heads. And then we can take those models and put them down into our code, into our software. So you might say this is all kind of super, good, but it doesn't sound very much like DDD. This sounds like the thing I learned at university, or the thing that everybody seems to do. This is just domain modeling, right? This isn't domain-driven design. And you're right. That's completely true, right? This isn't domain-driven design. This is just how we build software. But what I want to introduce now is how DDD builds on top of this to get a far better, to take far more advantage of this, and to get closer to the problem and closer to the understanding. Because the DDD is in the language that we use in all these communications. And that language is the language of the domain. And so also how widely we work with that language. And so, like I say, this is the first truly powerful concept. This is the first of the 3 concepts that is introduced in the book, and it gets introduced on page 17, so really early on in the thick book. And so here, Eric kind of says, as we talk to domain experts, we rapidly discover that their mental models go beyond find the nouns. So I don't know about everybody watching this or listening to this, but when I was at college, they would say you need to do a class diagram, and the way you do your class diagram is you speak to, or you look through your use case or whatever, and you underline the nouns, so the things, and you turn those into classes. And as Eric is saying, there's lots more. It's not just, there's lots more information up in their heads. So how do we get beyond find the nouns? So and I can't remember where I got this from, but there was a really useful idea that someone shared with me very early on when I started doing domain-driven design. And I want to share that with you now, because I think it helps how we can think about this. So the first part of the suggestion was that we think of domain experts as developers who can't code, right? So they've got this clever, rich, detailed model, but they have no idea how to write C# or Kotlin or Golang or any other language, right? Or Python or whatever. So they know it, but they couldn't make a computer do what they want if they tried. But they are very expert on the domain. There's a flip side to this, and this is the other important half of this, is that we do know how to code, right? We're developers, but we know nothing about, or maybe we know a little bit about, but we definitely don't know as much as the experts about the domain, right? And it helps if we think as we know nothing and they know everything, but then we can code, but they can't code, right? So maybe they can code because maybe they took a course, right? Or they have to teach their kids to code at school. But we pretend they can't code and that we can, etc. And so if we look like this, we can see there's an unequal distribution of skills. But if we want to build a model of our domain, of the problem in our software, we need to build a shared model. So how are we going to go about this? So what we need to do is build one which is explicit, so super clear, and it needs to be super clear everywhere. So to do this, we need to collaborate, and we must do it as equals. We can't, if we go in and kind of treat the domain expert as a supplier and not a partner, then we'll make lives difficult. And then what we do is we create this shared language, and we use it all the way down to the code. So even the code is kind of talking the same language. And so by working like this, we acknowledge that there is a big divide between domain experts and software builders, and that divide is an understanding divide. But what we need to do is do as much as we can to close this gap, right? If we want to stand a good chance of building software that solves real-world problems for our users, this is the divide we need to close. But this isn't all. So this is one of the key aspects of ubiquitous language. But there's another point that is important to make. So this is the next part. So we hopefully all agree that the importance of this communication and mental model sharing. If we think it's important, the last thing we want to do is make this divide between us and the domain experts bigger, right? Because we already don't know all the stuff we need to know, so we should try and get closer and understand things. But the problem is we developers and architects and technical people in general do make this divide greater, and I'm going to explain how. So the problem is that we translate. So and domain-driven design says when we translate, we fracture our language. And the translation is happening not between English and Norwegian or any other language. It's between the language of the business domain, banking in our example, but it could be any other. So I've done things in the legal system in Scotland, legal system in England, which is different. Lots of different places, different things. we're not aligning the jargon of the domain with the technical. And so I think sometimes one of the problems is we forget that there's so much jargon in the technical world because we use it all the time, right? We live in it and we understand it. So things that I mean, like words like servers, clouds, database tables, select statements, pipelines, like ThoughtWorks are pretty bad at coming up with lots of these new jargon words. Scrum, Kanban, Kotlin, C#, Go, Node, etc. And dare I say it, microservices, right? Microservices is another buzzword, another piece of jargon, which we're all using and we're all talking about. If we say this to domain experts, business people in our companies, they just think we're going, they don't know what, they shouldn't need to know what we're talking about, right? So why is this a problem? So the problem is, and I see this all the time, and I know because I do it too, rather than listening to and learning the jargon of the domain and adopting the mental models of the domain by using and listening and speaking that language, we instead impose our jargon. We take our jargon and we push it back on the domain experts. We force them to talk and think like we do. And so the jargon in our code isn't the same jargon that the domain experts use when they talk to us about their ideas. And because we're not talking to them in their language, they're talking to us in our language, we lose all the detail, the rich detail that they might be giving us. So this can't be true, right? So that sounds like a crazy thing to say, but it's true. So to hopefully prove it, there's two quick examples. So what we could say is, if we have a domain expert and the domain expert uses the language of their domain, so they say, so-and-so, Bjorn credits so many NOK to his account, right? And I think, if you're honest here, but I still do, I think balance plus, right? Or something similar. And maybe you work in banking, right? So you've got a slightly more detailed view of this, or in finance. But it's very hard for us not to kind of translate that immediately, because we're software developers, into some kind of way of the computer implementing it. Let's have another example. So so when a domain expert describes, again, in the language of the domain, how a customer opens a new bank account, they go into a branch or they go online and they open a new bank account, we think, insert a new row into the bank accounts table. Because we're like, okay, this is how we're going to do it. And the problem behind this is what we hear when we're developers is the mental models that we build. And then when we take that mental model, that's what we put down in code. So we're not taking the mental model from our experts of the domain, we're taking the technical mental model, the translation. And this translation weakens communication. So the subtleties and key details and the little bits, the key important bits of mental models from the domain get lost. So what you should ask, and I have learned, because I've done this quite a lot, why are balances credited and not incremented? Because if they were incremented, then we would say the balance is incremented, but balances aren't. Balances are credited or debited. And then why are accounts opened and not created? Again, there's a reason, right? But if we do this translation and don't instead go and ask why, what is the detail behind this, we miss this, and then we don't put it in our software. So the way we do is we go back to the domain and we use that language. So we use that language everywhere. So we don't just use it as in build a mental model and then go down and translate it. We take this all the way down to the code. So we use the language of the domain in conversations, in documentation, in stories and tests, but also in our code, right? We have classes and microservices and everything called things that exist in the business domain. And so therefore, this code will use the language that expresses the models, right? And the language that will be coming from the domain. So we're not translating or forcing our domain experts to change, we change for them. And so this is a first point, right? This is the big one. The rest are smaller than this, but this is what is meant by ubiquitous language. And so ubiquitous is a word that I guess doesn't get used very much in Norway. It definitely doesn't get used very much in the UK, but here it means the same language and the domain language being used everywhere, up to including in our code, right? So ubiquitous is kind of like everywhere and everywhere without exclusion. So always this one thing. And so if we do that, we remove the need to translate. And so therefore we unlock deeper, richer conversations with domain experts. And so therefore our shared understanding, our mental models become far more accurate and far more detailed and related to the problem, right? So key thing to understand, the medium might be different. So we might be doing this in code, or we might be speaking it, or we might be drawing pictures on whiteboards, or we might be writing user stories or whatever, or tests. That's just, it's still Norwegian or English or Java or whatever, or banking, right? So these are the things we need to do. And so this is step one to begin to tackle the user problem. So that's part one of DDD, right? So if you think I'm talking too fast and you're going to log off, so please tell me if I'm talking too fast, because I think Bjorn's going to look out for the chat. But hopefully I'm not going too fast. This is the first big lesson. If you just learn this, that's a good lesson to learn, right? So there's more stuff, but this is good. So quick break. I don't know if people can see, if Bjorn can see anything. Maybe nobody's asking questions because everyone thinks this is super obvious. But I'll pause for a little bit.
Well, I can't see any questions on the chat.
Cool.
Traditionally, an analyst will dive into the problem with domain experts and kind of hand over the scenarios and the descriptions to the team. But this isn't a good solution, is it? How should the team be organized to really get this language and this model?
So I completely agree. Although, and I come back to this later actually, because that is a very good question. In fact, there's a slide where I answer that question. So I'll not answer it now, but that's a great question, Bjorn. Because you're right, like how we're set up, you might be thinking, oh, that's not how things work now. And I'll talk about how you can kind of change stuff without, dumping analysts and all that kind of stuff. Everyone has a good role to play. We'll talk a little bit about that because there's a reason those folks exist, right? So because they've got good skills. So any other questions or none? Right, cool. We'll keep going. So I need to put a nice picture actually, as opposed to let's take a break, because it's not very nice to look at. So we've got the language everywhere, right? So what the domain experts say, what we say, and what our code says is the same thing. So that's quite nice, right? Is that enough? No. So remember at the start, we said the domain experts are developers who can't code, and we can code, but we don't know much about the domain. So just kind of listening to the language of the domain everywhere and just putting that in code isn't enough. What we need to do is kind of meet in the middle. We're not just like, scribes writing down what they say and hoping it compiles, because it won't compile, right? So that's maybe another thing you're thinking, oh, this won't work. You're right. And that's what we're going to talk about now. This is the second part, because this is also important. So hands-on modelers picks up exactly where we left off with Ubiquitous language, and it builds on top of it. And it builds on top of it because so far we've traveled in one direction, right? We've just listened to what the domain experts have said, and we've just put them back in the code, or maybe repeated what they say to kind of check that we understood it. And maybe we asked a question, so like how do I spell credit, or what does I can't remember, but there's a special type of Norwegian bank account which I had to learn to understand because I didn't know what it was, and we didn't have them in the UK. But these things are important. So I mean more than that, right? So what we want to do is go beyond this. We need to take our growing domain knowledge and the models we're building in our heads, and we need to put them into code, but we need to put them into code to try and solve the problems, right? Because we're building software not for fun. We're building software to meet a need, right? To make something in our users' lives easier. So as we do this, we'll frequently realize the model that we have in our heads won't work to solve the problem, right? And so when we hit these problem points, we need to take our puzzles back to the domain experts and use that to have a deeper conversation. And so we're having this deeper conversation. We're not just going to gain a deeper understanding of the domain and the language, but what we're going to do is we're going to change that mental model, right? Or maybe shine a light in a dark space, or kind of dig into a bit that the person hasn't thought about before, or has thought about but forgot, right? And we'll uncover the complexities and the ambiguities, right? Because a mental model, a human being is quite good at fuzziness, whereas a computer, computer code needs to be very specific, right? And if we just do a quick look or a quick listen, we won't uncover these things. So, but now we go to the code, we try and write the code, we discover it doesn't work, so we come back. And it's a nice quote again from the book. So it says, Eric Evans says, in having these conversations, you both go on a journey. And this is, like I said, this is why it's a partnership. Domain experts are usually, and this amazes me all the time, domain experts are usually not aware of how complex their mental models are, right? So they'll just have got used to building up this vast amount of information, but they won't think about it. They'll just use it to do their jobs. But we will make them aware of it because we have to understand it to get it into code. And so we do this, we get to these good questions by getting hands-on. And we need to not only speak the ubiquitous language, but we need to think in it, to reason in it, to crunch in it, and to code in it, right? And who does? We do. So this is another thing that's very key in the book. It's like, maybe you're not, if you're an architect, you don't get to write code all the time. You don't get to deliver lots of stuff, but it's important to kind of feel what it's like in the code, right? It's not, if you draw a whiteboard diagram, it's hard to know if that's going to compile. This is just domain-driven design saying the same thing to you, right? And it's not just us. So this is the first part to Bjorn's point. It's not just developers, it's all the other software delivery roles, right? We have to have these conversations with the domain experts and dig into these things. And so therefore, we're ensuring that the conversations are going both ways and that the ubiquitous language is being updated and grown from both directions, right? So ubiquitous language, another problem, and I used to think this until I went back to the book. I thought we just listened to domain experts and put that in the code. We as a group are creating our own ubiquitous language, and it's different for our project or our company from another company, right? Because maybe all three of us are building software for different companies in the banking domain. We can't copy each other's code because we're solving different problems, right? So therefore, we focus on different parts. And so as we grow our language to solve our problem, we update it and we grow it in both directions. And if we don't upgrade, if we don't feedback with the feedback loop, we'll fail. But, and again, this is to Bjorn's question, just as with ubiquitous language, there's not only one problem this second part solves, it also helps with the problem of ownership. So traditionally in software development, and Eric Evans calls this out in 2003, there is a traditional over separation of analysis, design, and programming, right? And that's, I think he says it's a disaster. I've copied and pasted that, or I think it's a disaster. But the thing we forget is software development is all design, right? The building is when our code compiles, right? So we've got a program to do that first. But when we write code, we're designing. And the problem is, too frequently, details get lost in disciplinary handoffs, right? So we hand off from the domain expert to the BA, and the BA then hands off to the developer, et cetera, and details get lost and assumptions get made. And there's a really awesome Alberto Brandolini quote. So Alberto Brandolini invented event storming, but he said it's developer assumptions which get shipped to production, right? So if someone talked to the domain expert, who then talked to someone else, who then talked to someone else, who then talked to a developer, it's what the developer thought they heard that gets shipped, right? Because you write the code. So you're like, we need to solve this problem. So what we need to do is we don't get rid of, and we'll talk about this in a minute, we don't get rid of QAs, BAs, other people, but we change the way we work because we need the people who wrote the code to feel as responsible for the model as the domain expert and the BA and all of the other different roles, right? Because if what I put into the code is not related closely to what's in the heads of domain experts, then the model in the domain experts' heads, which is where all of the goods information is not going to be getting down to the code, right? And that's why everyone contributing to the model must spend time contributing to the code. If you're a BA, we'll talk about this in a minute, you can pair with developers. If you're a QA, you can pair with developers, right? So they should see this in the code. If you get really good at this, and it's happened to me twice, and you've got a language which isn't Java, so you don't have too many semicolons and curly braces and all this kind of stuff, you can pair with domain experts, right? So if you've got a nice clean API, you can write some, Kotlin, you can do this stuff, right? So you can at least write tests. And this is why being hands-on is also at the heart of domain-driven design. Because if this doesn't get into the code, then what you're designing, all the DDD isn't getting shipped. So you've done it and you've almost succeeded, and then you failed at the last point, right? So that's why hands-on to modelers is the second key part. So I still haven't properly talked about Bjorn's question, so I'm going to get to that in part 2. But does anybody, while we have a little pause, does that make sense? Does anybody, any questions on the? I can just see Bjorn's face, so I don't know if there could be 7 into this or 700. I don't know.
It's not a question or a statement, but basically you're saying that developers need to learn the domain and become junior domain experts, if not senior domain experts.
Yep. This is the thing, and it's because you end up you start, and I mean, it's interesting. I've coded with, so in Scotland they're called procurator fiscals, so they are basically the state prosecutor. They don't learn how to program in Kotlin or Java, right? But they do get to the point where, because they're quite detail oriented, and you can sit down and pair with them, go, I think you said this, so you write a test, right? So you write the test, and they will correct my code because they're like, well, no, I didn't say that, and what you've put in the code is not this thing. So you build this shared kind of set of understanding, and you build this shared thing together. That's super powerful, and that's the next way to kind of get this stuff to work. So any other questions?
I'm not sure if we should save someone.
I'll save it. We can save them. The big thing is, if you see any questions, Bjorn, which looks like I've not explained something properly, shout, and then I'll re-explain it so we don't lose people. So, because the big thing is we build this core, and then we can do the next step. So quick reminder: the first concept, ubiquitous language, is a whole chapter, which is worth reading. The second one is a pattern, which I think is only like maybe 5 or 6 pages. So some of these things aren't big. But the third one is, it's not a pattern, it's not a chapter, it's just a phrase buried a third of the way into the book. But I think it's the key big thing. And it's multiple models. So why do I think multiple models are the third part of domain-driven design, the core part? So number one, they come directly from ubiquitous language. The reason multiple models exist is because ubiquitous languages are there. And the first hint of this existing is at the end of the ubiquitous language chapter. Eric Evans says, we've only had one model so far because we've only been talking about one ubiquitous language. If we had 2 ubiquitous languages, we would have 2 models. And so he doesn't mean 2 domains, he means within the same domain. So he famously uses an example of a cargo shipping company. He has multiple models because he has multiple ubiquitous languages still within the cargo shipping domain. So there's, So what does multiple model means? Multiple model means that if we discover another ubiquitous language, someone is talking in a different context, then we have another model, right? Because a mental model is a thing that I've got in my head because it solves a problem. So if I'm in a different context because I have a different problem, then I've got a different ubiquitous language. So the thing that is famous in domain-driven design is bounded contexts, right? But the reason bounded contexts exist, a bounded context is a thing to protect a ubiquitous language. So the context part of bounded context is the language context. So if I say something in a conversation to someone, okay, so use an example from where I'm working at the moment. So if I'm talking about a product when I'm working with a product manager, and then I talk to someone who's a customer of the same company and I talk about product, we're kind of still talking about the same thing, but the idea, the mental model of the product for a product manager will include the business model, will include the cost benefit, include all of the plan and all this kind of stuff. Whereas a product from a customer point of view might just be the apps that I download, right? And the fact it costs me $3 a week or something. So the word is the same, but the mental model is different. And you get loads of these different mental models. That's the context, so the situation I'm using the words in is the context, which is a language term, right? It's not a software term. The bounded bit is the fact there's a line around about them, which says this context is this here, and it stops at the edge of the line. This context is here, and it stops at the edge of this line. So without multiple models, bounded context would be irrelevant because we'd have just one big model, but we don't, right? We've got multiple models. So to make it a bit easier, because this is bounded context, which we're not going to talk about, but they're super famous and they confuse everyone. So that's why I'm focusing on multiple models. The easy way to think about this is first, if we think about it technically, right? So multiple models exist on a simple project or on a very, most simple IT projects. Is not a surprise if you think that in some circumstances, when things are working well, it's really obvious. So that everyone on the call knows that the data format of one system, like a CRM system, is different from the data format in an HR system, and you need to do data conversion if you're going to talk between the two. Those are 2 models, right? You know, and they might still be about the same thing. They might still talk about customers, but they're solving different problems, right? The problem is those are the easy ones to spot, but those are technical things, right? So we know we can solve technical problems. What we want to do is get better at finding multiple models when we're in the domain space, not the technical space. And Eric Evans calls it out, right? So he says, when the discrepancy is not with an external system, but within the same code base, it is less likely to be recognized. So remember we said earlier, domain experts frequently aren't aware of the specifics of the models that they have, right? So, you know, they're like, oh, crap. And I've had conversations, they're like, oh, I didn't realize I knew all of these things. I'd forgotten half of this detail. So they forget it. So they might not even realize they've got 2 or 3 or 7 multiple or, you know, mental models, right? That can be a big confusion. So they can flip context in their head when they're having a conversation. And unless you're super tuned into it, you won't hear them flipping. So you'll think they're talking about one thing and they're talking about 3 things. And so this is a picture of what it looks like. So this typically happens when communication at the domain level collapses. And it results in you typically thinking WTF, right? Because you're like, right, they thought they were describing this thing. And I thought I'd understood what, I don't know, what a quote was. And now they're talking about another thing. And this seems to be another kind of, is it another kind of quote or whatever? Or in the Scottish legal system, there are 3 kinds of warrants: a police warrant, a court warrant, and a something else warrant. And apart from the word warrant, they're completely different. But they would talk about them because they were talking about warrants. So we would be like, crikey, warrants can do all of these crazy things. And sometimes, you know, we couldn't figure them out. They weren't the same thing. There were 3 different mental models. So what's happening here, you know, you think WTF, probably you have more than one ubiquitous language, but it's all smushed together. And the reason is not because your domain expert is aware of it, but isn't expressing themselves clearly. It's because they don't realize they've got 2 mental models in their head, right? But it will be clear if you listen to the language they use. And if we miss out on this kind of detailed piece of information, then we're missing out on signals for a solution. And especially if we're trying to do microservices, right? And we're trying to split things up into smaller pieces. If the domain has an idea of how to split things up, if we can find those domain splits, then we're getting we're making a nice progress towards microservices. So therefore, what you need to do is be prepared for the situation happening, right? So number 1, keep your models clean, like when you draw them in diagrams, in your head, on your code, whatever. Keep each one, and the way to do this is keep each one focused on a single problem and know what that problem is. So then you have a kind of line in your head round about that model. So therefore, you know what problem that model is solving. And be proud of your model, right? So protect it, nurture it, ask questions about it, and get more stuff. And then let the language be your guide, right? Because if you hear someone talking about things and they say something which doesn't feel like it fits, you can say, oh, but are you describing solving this problem, or you're describing solving another problem? And they go, oh, no, I'm not describing solving this problem, I'm describing another problem. Then you know they're talking about a similar concept, but in a different model, because it's a different context, because they're solving a different problem. That's how you get the split, right? So be clear in your head what problems your models are solving. And that's it. So that's part 1. That's the black and white kind of by the book stuff. So I definitely recommend, if you are inspired kind of as a result of this, to read the book. You definitely don't have to read the whole book. You could literally just read the ubiquitous language chapter and the hands-on modelers pattern. And hopefully you would think that I hadn't lied to you. That's the idea. But then we'll go next section, we'll go into kind of these things aren't, you're probably thinking this isn't as easy as you make it sound, and you're right. So the next section is we'll go back to each of them and we'll talk about some of the challenges, some of the things that I've learned, again, to make them more solid and make them more hopefully usable. So then we get to the 3rd stage, which is microservices. We've got a good idea. So has anybody got any questions, or Björn, anything that wasn't clear? Or?
Well, how do you get the buy-in from the main expert to spend time to pair program with developers?
Oh, that's good. So, right, I've got a slide with that one, so I can. This is good because you're asking the right stuff. So, yeah, I've got a slide with this because you're right. That's hard. One way to fail at DDD is to not be able to get domain experts. And when I've succeeded best, when we've got like lawyers have come in, maybe one, like ideally you get them full time, but that's expensive, right? Or people in the banking domain, or call center operatives, or whatever. But if you can get them, you can move so fast because they've got so much of this stuff up in their heads. It really pays back. So, but yeah, so that's hard. So I've got a slide all about that. So, any other questions that anybody might have?
Has anyone asked the main experts what they think about developers? I'm not sure in which context that's asked.
It's interesting. It's very so. What was interesting was like, so this again comes back to the slide that I've got later on. It can be frustrating because we'll ask the same question over and over again. And what you need to do, and I get quite a lot of practice at this because I'm a consultant. So lots of my work is going into new companies and speaking to people I don't really know and getting to know them and building their trust. It works, but like you're right, sometimes it will really frustrate them because you'll ask a bunch of dumb questions and get them to explain obvious stuff. It's working, however, when you're asking them about the interesting, complicated, difficult parts of their thing. Lots of them will like talking about that kind of stuff. And then they're like, you get past the boring nouns. Yeah, there's a thing, and a thing. But then they talk about how they work and what the differences are and when this happens and when this doesn't happen and all these things. Most, in my experience, will really enjoy it because they get a break from doing this in their day job. And they feel that the person who is building the software to solve their problems cares about how they think. So it should, again, be really, I've said in other presentations, it makes it fun because you understand the problem and you get empathy for the person you're trying to solve the problem for. So it makes a big difference. So we'll talk about that a little bit more as well. I'm going to zoom through some of the next slides. All of the words I'll share the whole deck with all of the speaker notes because I'm reading the speaker notes out to try and slow down. So I'll zoom through some of the slides next so we can get to the microservices bit, which I think lots of people are interested in as well. So I want to leave time at the end for questions. But I'll share the deck with all the speaker notes so people can read them if they want. So there's probably a bit too much information in some of them, but we'll zoom past it and then you can come back and read it later on. So I'll now, like I say, go back and revisit each thing. And what I want to do is kind of deepen your understanding and maybe, hopefully answer some of the questions you've got but haven't asked yet. So, number one, ubiquitous language. The first key point, and I've said this already about 7 times, ubiquitous means not one model to rule them all, because we've talked about having multiple models, right? That's the wrong ubiquitous. What we mean is all the way down to the code, right? Especially microservices. Your microservices should be called things that your business domain experts recognize. And the functions and operations, I know they'll be maybe they're RESTful, right? But they will do things, so you won't have create account. I've seen, like an account service. Congratulations, you've created an account service. And this, my current, when I was in Norway, this hadn't happened, but I've seen this elsewhere. They have an account microservice, which is good, but then they have a create account as opposed to open account endpoint. And you're just like, you're close, but you've failed, right? So you want to have this all the way down. So, and the reason why is not just because DDD people are a bit crazy. It's because if you translate, you miss things, and you want to not translate. You want to keep using that language, right? Number 2, as Bjorn already asked, right? So this is super important. If you don't have domain experts, you can get there, right? People deliver software before DDD. People deliver software without DDD. You will get better, more long-lived, more, maintainable, evolvable, higher quality software if you take the experts' mental models and get those down into the code. Next question is, where do you find domain experts? So I've got a long list, and I think I tweeted a Twitter thread about this as well. So I can share that as well at the end. But there's a bunch of stuff. The key thing I've already kind of mentioned, you want someone who's interested in the problem. You want someone who understands it and not the manager of the people who understands it, because the manager probably understands it, but not the complicated little bits. You want someone who's interested in it. You want someone who isn't a developer, because I once worked with someone and I thought they were really good. And then it turned out that I was like, oh, but they had preconceived ideas. They were learning to code Python in their spare time because they were a lawyer and they thought it was fun. And they were telling us the solution because they designed it in their heads, and they were telling us what they thought, and what we wanted to know about was the problem, not the solution. So that's important. But they do, like I said already, need to be comfortable with lots of dumb questions. Oh, maybe the same question over and over again, right? Where you keep coming back and asking and going, I can't get this to compile. I can't get this to work. And the big thing is, like I said this already, but it's worth repeating. You want them to have hands-on experience. You know, so like some of the best domain experts I ever had was in a legal system that we built in the UK. It was to kind of make things more efficient. And one of the parts that needed to be made efficient was booking court appearance locations and dates for certain court cases. It turned out that getting the right court case in front of the right judge with the right people in the right location at the right time with all of the right stuff, that's so complicated, computers can't do it. So the only real reason we realized it was that complicated is because we had people who are called court clerks, and they know how hard that is. So we got an understanding of how hard that was, and then we built a system which didn't do it for them because we weren't that clever. We built a system which provided them with the information instead of them having to go off and find it from 6 other systems. And then they could take the decision. So a human being was still making the decisions, but we were providing them with information which we understood they needed to do that work, right? So that's another good thing, like a little point which isn't related to this, but by understanding domain experts things, you realize sometimes a computer system shouldn't be solving it. You should be serving the expert user, and they can do the stuff. And so the last thing, sometimes, and this is really good fun, although the first time it happens is terrifying, is when you have 2 experts who are telling you different things. So the best story I've got is I had 2 procurator fiscals in Scotland, one from Aberdeen, I think, and one from Glasgow, or one from Dundee. And I'm from Aberdeen. So they disagreed as to how this law in Scotland worked. So we're trying, and so our UX person went white because they were like, how can we build a system if 2 of the state prosecutors from different parts of Scotland can't agree on how the law works? We are doomed. And what we did was we stepped back and we got them to discuss it. So they were doing domain-driven design to each other, and they were going, "Oh, what's the thing? How can you And they took the pen, they were at the whiteboard, they were drawing the pictures, because they were bright people, right? They didn't know how to code, but they could express their ideas, and that was completely how their skill set worked. They solved the problem. They gave us tons more details of information about stuff. We could put that into our software, and we could solve what could have been a really complicated problem. It turned out to be like a simple thing plus a complicated thing, and we split the 2 things out. Because they figured out that they weren't disagreeing. They were thinking about what they thought was the same thing, but was different. So they pulled the 2 problems apart. And that's DDD, right? That's again, so, again, microservices, if you're trying to, things feel complicated, it's typically because you're 2 coupled or 2 things are in the same, even with just like basic object-oriented design. If something feels hard, it's because you've got 2 concepts crushed together, right? You can pull those apart, and domain experts will help you pull that stuff apart. So that's ubiquitous language. What about hands-on modelers? This is exactly Bjorn's point, right? So you read the book and it definitely feels like BAs, UX, testers, etc. Don't exist, shouldn't exist. Even architects, spit down an architect. If you can't code, it doesn't really like you. That's one interpretation of the book. What I think is, if we were good at this and we did what domain-driven design said we should do, we'd be doing it already, right? And we're not, because I'm doing this talk and I'm trying to spread the word about DDD. And I think that's because one thing that Eric Evans maybe has is Eric Evans has the kind of the inclinations and the abilities of a BA, a good analyst, and of a developer, and of a QA and a tester, because you read some of the later chapters and he steps back and he's thinking in a TDD style. So he steps back and he thinks about how might it work from the outside, then he thinks about the inside, then he's trying to break the problem down. We're not good, we're not all Eric Evans, right? I'm not. I haven't written this classic book. So what I do is I rely on and I work with and I pair with my colleagues in these other roles, BAs, QAs, and UX, because they will help us do lots of things. There's another pattern called modeling out loud. It's amazing. Like, I learned to get better at that. I know BAs who do that just because of that's how they think, right? And they're all about the language, and they're, lots of, I've done this presentation for BAs, and they're like, oh, half of this is really obvious. We do this all the time. And I hadn't realized I did this, because they're like, we don't get to write code, but we have to understand the problem. So the key thing is involve them, right? Pair with them. Don't, make it a handoff, but you can pair together as a group, right? And that's like the accelerate, cross-functional teams, work with them, put them to get working on stories and all that kind of stuff. There is a very good reason for them to be there. Next one, just a quickie. It's not in the book. But when I did the training course, and it works really well. And if you take my training course, the O'Reilly thing, we drive it not with UML, we drive it with tests. You can TDD your way towards DDD. So the way you get your hands on is you compare with a domain expert by writing tests. So maybe they never see the code, but your tests, the names of the functions, the names of the objects that you're manipulating should make complete sense to a domain expert. There should be nothing there that sounds weird. No frameworky Spring, stuff that they're like, what is a servlet? That shouldn't get anywhere near your domain code, right? There's patterns in the book to like wrap your domain code and all this other stuff, but that stuff should stay clean, right? So using TDD to help you do DDD is really, really key. A little bit about OO and functional. The whole book uses OO examples. It's loads of Java. So if you don't like Java, then I apologize, but you kind of need to read a bit of Java to read the book. Eric doesn't talk about functional, but there's a whole thing about DDD and functional. So the DDD Europe conference is going to be all online this year, and they've got some specific workshops on doing functional DDD. There's two people, Scott Vashlin, I think he's American, I'm not sure how to pronounce his name, and Debashish Ghosh, who I do know how to pronounce his name. They've got a whole set of stuff on functional DDD. And there's a whole chapter called Supple Design, where Eric Evans talks about how to refactor OO code to be functional. So he talks about no side effects, intention revealing functions, assertions, pre and post conditions, etc., etc. So you totally can. The flip side of this is a warning. Eric Evans has a big rant about procedural languages, which he hates, maybe I don't know why, but he thinks it's wrong. I agree, and I would extend it to data-centric languages. DDD is not just about the data, because the data is close to nouns. And the whole point is, and we'll come back to this later on when we get to part 3, we need some of the concepts from the back end, but we need to think about things richly. We need to stay as close to and in the mental model, which is rich, right? It's not like data structures and attributes and things. It's functionality, it's logic. We need to stay close to that. If we use a language which doesn't let us do that, then we're going to fail, because the language will pull us. It's harder to get closer to the mental models of our users. So that's why we need to not do it. So that's the first two. So what I want to do now is add a little bit of commentary on the feedback loops that we talked about. So we've talked quite a lot so far about the first feedback, the direction from ubiquitous language to hands-on modelers. Let's talk about the other direction. I've said it before, I'll say it again. Design is an iterative process, right? So we need to use the language and we need to apply it and then push the learnings back. So, it's not a one-way direction. It goes round in circles. And that's why it's important for modelers to be hands-on, right? And prevent a drift between the ubiquitous language and the code. So Eric talks about that a lot. He doesn't talk about another reason, which I think is equally important. And it comes back to the TDD. I think it's important to not just get things into diagrams on a whiteboard, but to get it into code, because, and maybe this is just because I'm not very good at holding lots of code or information in my head, but if I've got a set of tests which specify what my domain model does, I can work on and test drive a design of a small part of it. Then I can start looking at another part of the code, and the tests still stay there, right? So I'm doing red, green refactor. I'm running those tests. I don't need to remember what that part of the model does. My tests are checking that it still does it. I go somewhere else in the code base. I write some more tests. If the decisions and the things I'm learning in this part of the code base over here start breaking the decisions I made over here, my tests tell me that I've failed, right? They tell me that something is breaking in the model, and I get that rapid feedback, right? And what that rapid feedback, it's important, but it drives a key thing, which is another big thing in DDD, and that thing is breakthroughs. So breakthroughs are also known as, this is a quote from the book, when your model makes a sudden and significant leap forward in depth and focus, right? Your model gets richer. You've discovered something really cool, and you've like pulled these two things apart and move forward, which is really good. That's what you want with DDD, right? The problem is breakthroughs aren't techniques, they're events. So how do you get to them? And like I said, the one way is you've got your tests running and you're constantly checking that everything you think is true. But you can use this to your advantage, right? You cannot, if you're doing a science experiment and you have a hypothesis, You don't design experiments to prove your hypothesis. You design experiments to disprove your hypothesis, right? So you think, what can I do to prove I'm wrong? Because then if I don't prove I'm wrong, then my model, my hypothesis, my model is still solid. So you do the same with tests. You don't spend ages asking your domain experts about the things that you think you understand and you agree on. You focus on the things you don't understand and you think sound like they maybe will break the model you have and the understanding you have. Because you'll either prove you're wrong and you'll learn something, or you'll prove you're right and you'll learn something, right? Both of which are good because you'll learn more. So let's step back a little bit because this is super important. So there's two types of breakthrough. And at the start, we remember, because we're now going to move towards multiple models. We clarified the word ubiquitous. So ubiquitous isn't one model to rule them all. It means one language spanning a model and, the language and the code, right? So what we need to do is, if we have a first form of a breakthrough where we make our model richer and deeper, that's good. But sometimes we get a thing which goes, the model cannot work for these two things at once. And what we've done is we've split our model. We've had a breakthrough that split out the models into two separate models. And because we've discovered two different problems, we've discovered two different contexts, we've discovered two different ubiquitous languages, that's super key. And again, if you're getting to microservices, this is what you want to get through, right? You want to slowly step towards pulling things apart. And so within a context, a model in its language must be ubiquitous. But between the contexts, there can be great differences, right? You're allowed to have completely different ideas of things because that's the whole point of mental models. So what you need to do is really love that. That's not a bad thing. That's a good thing. There's a few comments on that, which we'll get to in the next bit, but it's the way to make microservices work. It's the way to split things up, right? You want things to be independent and separate. You don't want them to be all tightly joined together. And so then we'll get to the third concept. So number one, why do we have multiple models? We already talked about it. We get bounded contexts, which they're not unimportant. They're super important. And the whole second half of the book is all about the power you get by bounded contexts. So that's all good. There are, however, challenges, and this is I won't read this out. There's a really good blog post, and I've kind of cut and paste lots of it into the speaker notes, but I wanted to get to the last bit of the talk, so we'll not go into detail. But people typically say, if we've split things out, you split your models, you'll end up with, say, some concepts in two places or multiple 4 or 3 places in these separate models. That's not dry, and we're software developers, and so we can't do dry, so therefore DDD is wrong. That's us misunderstanding. I include me because I used to misunderstand this. That's us misunderstanding dry. Dry is about knowledge, not about the repetition of like individual pieces of code. So there's a really good blog post that I recommend you read by Matthias Ferreis, and it's called "Dry is About Knowledge." And again, if you can Google it, or you can look on the notes because I've taken a kind of summary here, but he's saying, like repeating the same piece of information in two places, if it represents two pieces of knowledge that are separate and might change separately, that's fine. We should have those separately. But if they're the same piece of knowledge that should never change separately, then they should be dry. We should have them in one place, and then we don't have two models. But inevitably, when you split them out, it'll be two things with the same name, but represent two different pieces of knowledge. So that's a key thing. Two other quick things before we get to our last break. Canonical data models are the way to fail, because someone thinks they've designed a data model which covers absolutely everything. You might have a reporting model, which is fine. So then all of your individual microservices can feed into another reported bounded context, right? Because what is the problem I'm solving? The problem is reporting. So you feed it into a data lake or a big data warehouse or whatever. But that doesn't mean that every single microservice should map onto a piece of this canonical model. Microservices solve individual problems, right? And they have their own individual data models. And that was before microservices came along, right? That's just what Eric Evans says. And the last key thing, there's a very famous book, which I won't name, but it talks about nested bounded context. Nested bounded contexts don't exist. We're talking about splitting. You don't half split something, but half keep it together. You either split it all the way or you keep it together. So you don't get, like, nested is like one thing inside another. They're not, they're completely separate. So that's part 2. So we can have another small rest. I need to take a drink of water. hopefully what I'm aiming for is at least everybody on the call, and maybe if you're watching this afterwards, can name the three things, and maybe explain what they are. And maybe you're thinking, maybe you've got a screenshot of some of the list of things that can go wrong or that can be difficult with them. But hopefully we've definitely got at least enough in our heads to know that when we take the last leap into the last bit, which hopefully will be 10 minutes, and we can have 10 minutes for questions, that all makes sense. So does anybody have any questions? And I'll shut up while I have a drink of water.
There is a question, but I think you maybe answered it with this iterative model where you refine the model as you learn more. But if a customer or domain expert has decided on a name for something you have to make a model of, and this name just doesn't make sense, it's too generic, or how do you convince them to reconsider it?
That's a very good. So it's the key way to do it is to point out, because so there's two techniques. One of them sometimes doesn't work. So I will, and this, I can get away with this because I'm a consultant. I've sometimes said that's not a good name. I think we should call it elephant, which is a terrible name, and everyone agrees is a terrible name. But then at least we know this thing, and we're like, right, okay, what we're trying to do. The problem is, I did that on my last project, and the word elephant was being used 3 months later until we finally replaced it. But also, I could call out and go, that's fine, but you want to make it clear, because when you get these things right, like when you get code right, it just, when it's clean, it feels right, and it really, you feel like, so things like if you get DDD right, your layering and your complexity and all that stuff just happens automatically because you have a nice, the name of your method describes the 17 lines or the 5 lines of code within the method, right? So you've got the detail in the method, but you've also got the name of the thing. Same for the class, right? So, and same for packages and everything. If you get the right name for things, you'll hear the domain experts using this term as a shorthand, as a shortcut to explaining this more complicated thing. When that bleeds down into the team so that everyone is using this word because it's the simple, easy way to communicate, there you've got it. If it isn't working, I would make it clear that it's not working. It's like there's still confusion around this thing. It's not, and finding names is hard, right? I say that DDD is the best way to solve the hardest problem in computing, which is naming, and cache invalidation, right? It doesn't solve cache invalidation, but sometimes they don't, and this is the other thing, right? Sometimes they don't have a name either, and they're like, we also have problems with this too. Then at least you can go on a journey together because you're creating this ubiquitous language together and say, right, we need a name for this thing. And like I say, sometimes the word elephant or another, a word which is clearly wrong helps. You got to be a bit careful that you don't ship a product with an elephant class in there or something. But yeah, call it out, because if it feels uncomfortable, then that's a signal that something's wrong, right? That all of your gut feeling when you're like, I'm not sure, those are valid. That is a feedback that something needs to get a bit clearer, right? So
yeah, and it is important to call it out and not just accept it and keep it in the model.
Yeah, like I say, it's iterative, right? You got to bring it round. You don't just, and it maybe you're wrong. Maybe it just is a good name, but you're just not understanding it. But then you're like, right, okay, so I'm not understanding this. Can you help me? And like I say, I know it's easier for me as a consultant because I get to pretend to be stupid all the time, because most of the time I am, because I don't know anything about your company when I join. So I get to ask the dumb questions, but you can say, this is maybe a dumb question, but all that kind of stuff. So, right. So if we fire through the next lot, and I'm going to try and get this done in 10 minutes, and then we can have some conversation at the end if we get a chance. So how do we get there to microservices, right? So that's the presentation I've written, but then I've kind of put this other bit on top for Bjorn, because I think this is a very good thing to talk about. And if you've got this basic set of stuff, we are ready to go to get to microservices. So what we need to do is put 3 more things on top, right? So hopefully it's already obvious the things that if we're looking for microservices, what we've already talked about, you can maybe get an idea of where these things might be going to get to what we want, right? Because we want to be business focused, definitely, right? Microservices is supposed to be business focused, and we want to split things up so multiple models feels good. But we need 3 more things, right, to get to failure isolated, separately deployable, nice, good size microservices. So we go back to the book. So part one, or I said at the start, ubiquitous language and hands-on modelers is in the first part of the book. That's called putting the domain model to work. Multiple models is everywhere. Next three are in the second part, which is called the building blocks of model-driven design. So where we need to get to is aggregates. Aggregates, I will make a bold statement, have a one-to-one relationship with microservices. Fact, right? Not all microservices are aggregates, but all aggregates are microservices. But to get to aggregates, we need to have a quick chat about entities and value objects. So let's do those in turn, and then we'll get through them quickly. We'll get to aggregates, and we'll see what we get. So first up, entities. Number one, again, remember we said, if you hear entity, you think entity relationship diagram, you think table in a database. You need to resist the urge to bring that knowledge, that kind of technical jargon into your head. Don't think about databases, because the DDD idea of entity is different from a database table. Fact. So try hard to push it back. But the goal of entities is clear. So quote from the book, they are not fundamentally defined by their attributes, which a table would be. They are defined by a thread of continuity and identity. So this is why entities are new, right? And they're not like entity beans in EJB or any of that kind of stuff, because that kind of went wrong. But they're things which have an identity, right? The thing that defines them is their identity and the thread of that identity. And the reason, again, that they're called out is because lots of modeling, you don't just do find the nouns, but you find the attributes, right, in the behavior. Entities aren't even about attributes or behavior. They're about this thread, this life cycle, right? The kind of the creation, the changes, and the destruction of the thing. So if everything for an entity is identity, there's a little bit more we can hear about it, right? So what you must do in the model for your entity is define what it means to be the same thing. So that part of the model, the bit that you say is an entity, what its job is to say what it means to be this entity. So what you need to do is define a means of distinguishing every one, regardless from all of the other entities, regardless of its form or history, right? Are they the same? Are they different? And the other key point is, entity isn't necessarily a thing that the thing in the world has. It's typically a thing that human beings have put on that thing to give it an identity, right? So, and the reason human beings have put a kind of identity on that thing is because we need to solve a problem. So we'll have an example in a second. But so we go back to ubiquitous language. What is the problem we're trying to solve for our users? And that will tell us if it's A, if it's an identity, so if it's an entity, but also B, what its identity might be. So a quick example, right? So I've been to JavaZone, and so Oslo Spectrum, we might be building a system to do seat booking at the Oslo Spectrum. So, and we think that the seats might be entities, right? And the reason, but when might a seat not be treated as an entity? If you're thinking that you're taking bookings for an unallocated seating gig, you're right? So the seats are still the same thing. They're still the seats in the spectrum. But, if I've got a ticket, it won't have a seat number on it because I don't care. There's just a certain number of people who can get into the venue. So a person with a ticket will be an entity, and it'll have an ID, right? But the seats don't. If I'm building a system which has to manage the seat specifically, and I can buy a specific seat, in a specific location, that's different, and then a seat will be an entity. So this is an example from the books. You can go and read a lot more about it, but it's kind of, it's sometimes people trip up because they think a thing always is an entity or not. It depends on the problem you're trying to solve, right? So, and the problems change based on the ubiquitous context, right? So you might have the same thing, like a seat, in two different models in your system, but one might be an entity and another one might be different, right? So here's the tips. Make identity primary to the definition of your class, because entities are classes, right? Keep the, I'm just going to move this, class definition simple, focused on the life cycle, right? Everything else, bullet point number 3, you get out and put that, like behavior, attributes, other things, you put them in associated objects, like associated objects that are related to this entity, and the entity then coordinates the operations of those owned objects, but it doesn't necessarily do anything, right? It's just worried about being this thing in the life cycle of the thing. So that was quite quick. There's a lot more about entities, but that's what we need to know to build stuff up, right? So I was going to say, let's take a break, but let's keep going. So next up is value objects. So to get to value objects, if we take a step back, we go to entities. We said before, beyond identity issues, the other thing entities do is coordinate operations of things they own. So what do they own? They own value objects. So entities are all about identity. Value objects are the opposite, right? So a value object has no identity in the system. So the best way to treat them, they're created to represent elements of the design we care about for what they are, not who or which they are. So if you do a search and you find one value object or another value object, as long as it meets your criteria, you don't care. Whereas if I'm looking for an entity, I want the entity I'm looking for. It continues, when you only care about the attributes of an element, make it a value object. Make it express the meaning of the attributes and give it the related functionality, so the functions, right, the methods. Treat the value object as immutable, don't give an identity. So this is how you decide if it's a value object or an entity. Based on the problem you're solving, that's what you do, right? And then you can split between the two. So that's it. Just to be super clear, value objects are immutable, don't give them any identity. So how do we use them? So typically they're the things we pass as parameters, right? They're frequently transients, they don't live for long, they're created for an operation, then thrown away. They're used as the attributes of entities or attributes of other value objects. So they're just kind of, things like an address or a name or a, sometimes they can get quite complicated, but they're just, one is the same as another one. So there's another great example in the book, which is, and it's on page 98, it's called, is address a value object? Who's asking? And basically it's got two examples. It says, you have an address class. In situation one, we're building a system for an online store and they treat address as a value object. So if me and my roommate both order something from this online store, and this is maybe before they've tried to optimize their supply chain, right? But they just care about selling stuff. They don't care that me and my roommate's parcels are being shipped to the same destination. They'll ship separately, and that's fine, right? Because they've sold the things. That's what they care about. In a postal service provider, right? They really care because they want to not go to the same house twice. They want to go to the house once with the two parcels. So it's an entity address in a postal service, whereas a store, it'll just be a value object. And so, as you can see, is it an entity or a value object? The answer is it depends. And the way we know is we go back to ubiquitous language and hands-on modeling, and we listen to what we've got and we figure out what we're trying to solve, right? So, and remember, we don't have just one model. So again, hopefully this again gives you, this is again to give you the power of DDD for building microservices. You can, at the same concept, if it's in different models because you're solving different problems, maybe you've got one system, you're Amazon, right? So you're selling things, but you're also shipping them because they can save money by on shipping costs. But that's two different systems, right? Two different bounded contexts, two different problems, two different models. So you've still got address, and maybe they talk to each other, but they represent it in different ways in different things, right? So that gives you the power to be separate. So we're going to not take another break because we're going to keep going. But the last one is aggregates. And I said already, aggregates are microservices, right? So if you read the Blue Book, even though it's written in 2003, and this is one of the reasons why I unashamedly love domain-driven design. If you control H'd in your head when you read the Blue Book, and every time you saw the word aggregate, you replaced it with microservice, absolutely everything makes sense. It completely reads. So let's see what it had to say in 2003. So let's talk about aggregates. People think aggregates are hard, and I think the reason is it's the only time that I can think of in DDD where the thing, aggregates, don't come from the real world. So we talked about all of this stuff. Listen to your domain experts, take their mental models. Aggregates are something that we have to take from the world of software to be able to build something, because the real world is what's modeled in our domain experts' heads. Let's find out, right? So I've got another slide. So we talked about ownership of entities, right? And so entities own value objects might own other value objects, entities might have relationships to other entities. In the real world, stuff is really super tightly coupled. And if the word tightly coupled in a presentation about microservices makes you get scared, that's right? Because the way to fail with microservices is to be tightly coupled. So we need a tool, a thinking tool, to go into these models and kind of split stuff up. And that thinking tool is aggregates. So we need groups of things and aggregates of those groups of things. And so the aggregate pattern starts, right? Aggregates, this is the start of the pattern. It says minimalist design of associations. So like not having every association ever that this thing knows about in our model, simplifies traversal to getting from one thing to the next thing, and limiting the explosion of relationships, right? So that means, as a consequence, it means that we don't have to trace long paths through things, and we get these more loosely coupled things. And that's what we're looking for. So aggregates solve the problem of joining things together and saying how joined together they are. Because if we want something to be independent and loosely coupled, we don't want one change to have, 17 other things have to change. We need to say these things change together, and these things change together, and these things change together. And getting the scope of those things wrong has super bad consequences, right? And a model is too big a scope. So you need smaller bits inside it, and those are the aggregates. And that's all they do. So they sound a little bit, they maintain invariance between groups of associated objects. And if that sounds a little bit like a transaction, you're right. And this is why, again, I said, this is the one time it breaks the rule of not taking things from the technical world. We're guaranteeing consistency, right? Just like a transaction does. And so this is why we're cheating. And I think this is why people find aggregates hard, because they've got so far in domain-driven design and understood that they're not supposed to bring in all these technical concepts, and then aggregates come along and break the rules. So we're not thinking about database transactions, but we're stealing the idea from database transactions, right? The reason being, it might not be a database transaction, it might be another kind of transaction, but it is a transaction. It's a set of things which change together, right? And as we know, if we design transactions which have too broad a scope, our systems don't scale. Same thing, right? So remember, this is the back thing. They're made up. They don't come from the real world. They're there so you can split stuff up and get to their thing. And so what they are is they're a set, as the quote says here, there's a set of rules for implementing transactions that modify objects. And what's the scope of an aggregate? An aggregate is an object cluster treated as a unit for data changes, which has a root and a boundary. So just like another smaller kind of thing within a bounded context, right? The root is a specific entity, and the root is the only thing that outside objects can hold references to. So if you think of that as your kind of the bearer of the API for your microservice, that's exactly what you want, right? So again, I think hopefully I've explained, I've gone pretty fast, but I want to get to microservices. I definitely encourage you to read the aggregate pattern, because it's only like 6 or 7 pages, and it'll give you, it's just got basically a load of rules. And if you meet the rules, you will have a nice clean set of microservices. So we've done it. We've got all the way there, right? So quickly summarize: entities, model identity, and relationships. Value objects are the immutable attributes and the logic that goes with them. And aggregates are a set of rules to group those into nice kind of manageable microservice level type things. So the last thing is, we go to our last slide. How does this map onto microservices? So at the center, it says small autonomous services, and that's what we've got, right? So we could use that to describe aggregates. They're definitely, small and autonomous, and they're things which go together. There's other bits on the diagram that I also want to talk about quickly, right? So we've said modeled around business concepts. That's pure DDD. Next up is hide implementation details. That's one of the things that aggregates gives us, right? So we said the last bullet point of aggregates was you can't talk to like something hidden inside an aggregate. You can only go through the root entity. That's pure aggregates, right? And immutable value objects being passed back and forth as DTOs and stuff, that helps too, right? Then comes decentralize all the things. Aggregates gives us this too, right? They make sure that we think about business level transactions. So the idea of a transaction, but at the business domain level, not at a database level. And they make it, because we put this in code, because we have an aggregate in our code, we can look at the code without having to look at a schema, without having to look at other sources of information to understand what's going on. and then we can split things up. And finally, there's the concept of deploy independently and isolate failure, right? And that's where our aggregates come in handy. And the last slide of this presentation before we open up for the 4 minutes at the end for questions. There's a quote which I'll just end on, because this is a quote not from the Blue Book, but it's from a pamphlet that was written by Eric Evans. And he says, for aggregates, use the same boundaries to govern transactions and distribution. So he wrote this in 2003. That's a microservice, right? So we just say the boundary of the thing tells us what changes together, but also where I can deploy it. Can I deploy it independently? And that's what microservices are. So when I saw that, I knew that this was, aggregates were microservices. And so hopefully by applying this kind of journey, these kind of key ways of thinking and these 3 patterns, value, objects, entities, and aggregates, there's a ton of other stuff, but if you wanted to get value in your microservices, this is what I, in my biased perspective, think you should do. So you get the best of both worlds. That wasn't the last slide. This is the last slide. Does anybody have any questions? There's probably too many questions now.
Well, I have a question that has raised heated discussions at
cool.
Marathon. You talked about the ubiquitous language, and it's important both the domain expert and the developer agree on that, and we shouldn't translate the terms into some technical development terms or other things. But there's another kind of translation, maybe not for you, which is English, but should we translate the domain, the Norwegian domain, to English?
No.
Or should we just use the Norwegian name in the source? And
this is a really good question. So there's a really good presentation on domain-driven design from some Spanish colleagues, and all the slides are in Spanish. So no, you shouldn't. So because there will be, like I said, there's types, for example, because you would miss things, right? When I was in Fornebu, there was a type of bank account, and I just thought it was a type of bank account, but there are certain cultural types of bank accounts in some of them, not just Norway, right, but various Nordic nations. And there's not just different rules, right, but there's different kind of cultural expectations and things around about them. If I'd have missed that and I'd have not and said, so when we spoke to domain experts, they would describe it. If I'd have just gone, so you mean account? I'm doing the same, like you say, I'm doing the same thing, but not from a technical perspective. I'm doing it from a UK banking perspective, right? Because this is, I did frequently say, so this works in the UK like this, it's how it works in Norway. But that was good because then they could say, oh, no, actually, this doesn't happen. Or this is set up for, so in UK, we have like student accounts with lower tax so that you can save for your kids to go to university. Other countries have, different types of things. We could have those conversations. So we definitely shouldn't lose that richness. There's another example. So the Scottish legal system, the English legal system is I think Roman. The Scots were famously never defeated, right, by the English, although we were a few times, but we were never conquered, right? So the Scottish legal system, lots of it is in Latin because it's very different from the English legal system. We ended up having classes and functions which were Latin phrases because you couldn't just translate them. They meant certain very specific things. And we wanted our code to be looked at by, or at least the test to be looked at by our lawyer friends and said, yes, that's correct. Or you can't have a blah, blah, blah. I can't remember what the phrase is, but there was a legal Latin phrase for they didn't turn up to court. But it meant a lot, right? This was shorthand for a super, different legal proceedings would happen because of this thing. So we couldn't say didn't turn up to court. We had to put this thing, and then it made sense to them. So translating is if I was in Norway, I should learn Norwegian to understand that. You shouldn't have to translate to just because everyone uses English when they shouldn't have to. So
yeah, because it's hard to talk and reason about the code if it's not in the same language as the model.
Yeah.
Yes, we are running out of time.
Yes,
I will definitely reread the chapter about aggregates and replace the terms with microservice.
Yeah, it's super
as you said. Where do we go from here to continue the DDD journey? You mentioned your course. It's on a slide right now.
Yeah.
But any other resources you could recommend?
So there's there's lots of other, I haven't read Domain-Driven Design Distilled. So everyone else recommends that, and I think it's good. But this is, well, you can't see it. So it's called, what's it called? The Anatomy of DDD, and it's so thin that you can't see it on the screen. This is like super awesome, and it's like 24 pages. It's free, but you can pay for it on LeanPub, so like give Scott Millett some money. It takes all the stuff we've talked about, but it's really visual, and it puts it together nicely with some different examples. It would be cool if you came to do my course. That'd be really good, because we get hands-on. We write tests, right? We write code and we do this stuff. Or I would like go back to the book, or if you haven't gone back to the book, get the book and just read the bits that we've talked about here, because there's not that many of them. There's loads of other bits, but if you read these in the order we talked about them, you'll get some benefit, and then maybe you can go back and look at other stuff. It's interesting if you've done this and then you read chapter 7, because we've got a reading group at my current client. Chapter 7 takes these ideas and steps it through and solves a bunch of problems and gets to aggregates and performance tuning and loads of cool stuff in the space of 20 pages. And it starts off with what looks like a nice domain model, and by the time it gets to the end, it's so expressive and so clean. So again, I think you could, if you read or maybe listen to this talk and then read chapter 7 of the DDD book, that's a really nice start. And then there's virtual DDD. So I know there's a bunch of Norwegians on there. So like Trond, who I can't remember. I think he's one of the big chief scientists or something, or someone at Sienta. He's running a workshop also at the DDD Europe conference, which the tickets are on sale at the moment. So none of which I'm not getting paid for any of this, but it's a really awesome community. The DDD community is super welcoming as well. So definitely, look at and it's very European. So there seems to be like a European centric thing to it. So definitely check out all of those things and get involved, because that's the reason I'm doing these talks, is because I think this stuff is awesome and it solves problems, and it makes us better software developers, right? And better architects, and we do a good job, right? So I think this will make us better, even better still.
Great. And if people want to reach out to you, your Twitter handle is at the bottom of the page.
Although, excuse me, so my phone's broken.
Well, yeah.
So I can't reply immediately, because I need to get my 2FA working. So when my phone gets fixed next week, I'll be able to reply. But please, at me or follow me or ask me questions, and I'll reply. So that'd be really cool.
Okay. Thank you, Andrew, for spending your afternoon with us and sharing your insight into DDD with us.
Yeah,
and Java Bin Online will be back in about a month's time with a new topic, so stay tuned.